This is AS Stats and we're on Unit 2 and it's 2.2. We're now looking at measures of spread. So the first part was looking at measures of central tendency, mean, mode, median. Now it's how spread out the data is. So let's take a wee look then at what we have here. So measures of dispersion are used to represent, which is the same as spread, used to represent the spread or variation within the data, since it is unlikely that all the values in a data set will be the same. First of all, range. The range is the difference between the largest and the smallest value. For continuous and group data, we use boundaries. It's the simplest measure of spread. It doesn't depend on the number of items or anything. The problem is the disadvantage is then it's going to be limited in use and it's affected by extreme values. I chatted a wee second ago there about the range, about you guys all doing a test, all scoring about 20% apart from one person that gets 95%. So if we remove the 95% person, the range is about 6 or 7, but with the 95 then it's totally, totally changed. So that's what it means affected by extreme values. Your previous example that you've just done with the people earning the money and then the managing director getting £100,000, if you work out the range there, it's totally marred and ruined then by the extreme value there. So the range really isn't much use and that sort of thing. Slightly better version then is the interquartile range, and you need to sort of know what that is. So one way of refining the range so it does not rely on the most extreme values is the IQR. The quartiles divide the ordered data into 4 quarters. 25% of the data lie below the lower quartile, 75% lie below the upper quartile. The IQR measures the range of the middle 50% of the data. So it's Q3 take away Q1. And Q1 is a quarter of the n plus 1th term. Q3 is 3/4 of the n plus 1th term. The IQR is usually used alongside the median. Advantages. Can you see it? More useful than the range because it focuses on the middle 50% of the distribution, not influenced then by extreme values. So that 95% I was talking about, someone getting in a test wouldn't then be affected by that. Again, disadvantages is kind of limited in use. The one we're going to be learning and knowing and loving then is our standard deviation, and it takes into account every piece of data you have, although it's a bit complicated and it's hard to understand and long to calculate. Another way of measuring spread is to calculate the standard deviation. This uses the mean of the data. This is the mean of the sum of the squared deviations from the mean. What you do is you take each piece of data effectively and you work out how far it is away from the mean. Then you square that and square root it, and it's effectively the average distance from the mean. Advantage is it uses all the values and it's much more mathematically. The disadvantage is it's long to calculate and hard to understand, and if you turn over the page you will kind of see the exciting formulas then we're going to be dealing with then on a regular basis. So so here is our standard deviation. It's the square root of the sum of, and this should make sense to you. So these are all the pieces of data. Say, we did our test, there are 15 in our class, if that's right. So we get all your marks and we take away the mean from them. We square them and we add them all up. We divide by how many there are and then we take the square root. That's effectively what you're doing to find the standard deviation. There are other ways of working it out. This is just the same formula rearranged, and it can be much easier to use. We're going to use this one. The problem is if the mean's an awkward number, which you'll find in this first wee example here, then taking that away, taking each mark, taking the mean away from each mark kind of gets complicated, and so this formula is sometimes better to use. From a frequency table then we tend to use this. So sigma fx squared over sigma f minus the mean squared. So if you have everything in a frequency table, it's easier then just to use that one. One thing worth a mention right now is that in a lot of your questions it's population or sample. Population means everything, as in the whole amount of data you used, whereas a sample, you've kind of taken a sample. So if the question states that the data is a sample, then the formula used is sigma f minus 1. So instead of dividing by the amount of numbers that there are, which we're kind of doing in this one here, you take 1 away from that and you're dividing then by the n minus 1. We'll be going into these formulas kind of in more depth, and to be honest, at this stage you're going to be using your calculator, and your calculator does it. You just type in the data, your calculator will work all this out as well. Alright, but we'll chat about that a bit more in a minute. Final thing then is variance, and that's the square of the standard deviation. Quite often we work out the variance first, and then to find the standard deviation we take the square root, and that works it out then from there. Let's take a wee look then at example 3. So example 3, a group of children were asked how many pets they own. The results are 0, 1, 1, 1, 2 and 3. Calculate the standard deviation of the number of pets owned. First of all, we need to work out the mean. So we're writing that then as x bar. Dead easy. 1 plus 1 plus 1 plus 2 plus 3 gives me 8. There are 6 numbers, and so it's 8 over 6. Or if you want then 4 over 3, or 1 1/3. I'm going to use a bit of a weird formula here to try and work this out. Effectively, what you want to do is take each of these numbers and then subtract the mean. Because the mean isn't a whole number, it's easier if we kind of do it this way here. So I'm going to set it up in just a strange way. Just bear with me for the minute. Again, this will make sense probably in a couple of chapters' time, to be honest. But if we do that, it's the sum of x minus x bar all squared. That's the same as the sum of x squared minus n x bar squared. And I've written then, use this one because x bar is awkward. And what we're saying is because it's not a whole number. Alright, so the sum of the x squareds looks complicated, but it's really not. 0 squared plus 1 squared plus 1 squared plus 1 squared plus 2 squared plus 3 squared gives us 16. That means this wee thing here, then our sxx is going to be sum of x squared minus n x bar squared. So that is sum of x squared. We've just worked it out. 16. Take away n. How many numbers are there? There are 6. And then it's going to be 4 over 3 squared. If you put that into your calculator, get it out, you get an answer then of 5 1/3. Here's what we're doing. We're sort of using this formula here, but we're going to divide it then all by n. I've multiplied the mean by n just to divide it by n again to make it all work out for us. So our standard deviation then is going to be the square root of this number, 5 1/3, divided by the amount of numbers there are. If you put that into your calculator, you will get 0.942, and that's our standard deviation. Alright, standard deviation for population, it's good to start to get used to this sort of thing, is going to be the same almost, but it's 5 1/3 divided by 6 take away 1. And if you put that in your calculator, you'll get 1.03. My advice is, I think you won't understand this bit just quite as yet, but bear with me, and we'll kind of go through some of the calculator stuff next, and you'll be able to work out what's going on then from there. Alright.